Today we're talking about absolute value inequalities. Inequalities are things like less than or equal to, or greater than or equal to is involved, or less than or greater than, instead of an equal sign. So that means that we are going to have a portion of the number line that can work. So greater than and greater than or equal to are both going to shade going towards the right. Greater than is going to be an open circle, and greater than or equal to is going to be a closed circle. Less than or equal to is going to be shading towards the left, left for less. And again, less than or equal to is going to have a closed in dot. And that means that when we're working with the interval notation, the closed dots are going to be the square brackets. This would be something like this, going over to positive infinity. So starting there, going to positive. Or in this case, it'd be negative infinity to some number that we stop at. When we are dealing with greater than, it'll be the opposite of than less than. And so when you deal with greater than versus greater than or equal to, we're going to have parentheses on both sides. So it'll be some number, comma, infinity. And for less than, it's going to be negative infinity, comma, some number. Now, when we have inequalities, the rule that just says or in the middle, like we did for the equations, isn't going to be the same. Greater than, and I think of it as great or than, is going to have or in the center. And we're going to be looking for any spot shaded. And when we are dealing with less than is going to be and we are looking for the overlap, less than and it's looking for the overlap. So you're looking at what's shaded with both of the things on each side. So and for less than, or for greater than. So first off, on this first problem, is my absolute value by itself? Yes. So that means that we can go into deciding, is it an or is it an and? And less than means and. And so that means that when we solve this, we're actually going to be looking for where do they overlap. So just like the last time, we have the 2x minus 5 is less than 7. But the other thing that's going to cause us changes is this entire side from the less than on is going to flip on the other side. So we have 2x minus 5 is greater than negative 7. So take note that both the inequality symbol and the sign change. Think back to when you were solving inequalities and you divided by a negative. It's because of that reason that inequality symbol changes. So we are going to go ahead and solve both of these inequalities. We add 5 to both sides. And that gives us 2x is less than 12. Divide by 2 on both sides. And that gives us x is less than 6. You do not have to do like a full-on number line. When I do my number lines, I mark the important pieces. So knowing where 0 is important. Knowing which side of the number line the 6 is important. But you do not have to take and mark every single detail whenever you do a number line for me. So on the other one, we have plus 5, add 5 to both sides. And we have 2x is greater than, this time it would be negative 2. divide both sides by 2. X is greater than negative 1. And so I come here down to my number line. I'm going to put the negative 1. So now we're going to shade this out on the number line. When we shade it, we need to decide, is it going to be open circles or closed circles? And so from the 0, or from the negative 1, it's an open circle. And I am shading towards the left, for x is greater than negative 1. So I'm shading this way. For 6, I am open circle again, but this time I am shading towards the left because it's less than. So my overlap is right here in the center. Your answer is going to be written in interval notation. And when we have interval notation, we need to have our start point and our end point. And this time, our start point is going to be at negative 1. Our end point is going to be at 0. Or at 6, excuse me. So we can't be at either one of those locations, so they're both going to have parentheses. Negative 1, comma, 6. And that is your answer. That's not an order pair. This is the interval notation, meaning from negative 1 to 6, any number I choose, it could be negative 1.3, or excuse me, 1.7821, or it could be any number in that range. It doesn't have to be exact. They will work and they will make this true. So there are going to be multiple numbers that will work to make these all true. So let's look at the next one. First off, we need to identify, is the absolute value all by itself, or is there anything on that side with it? Well, it's all by itself. So now I look at my sign. Is it greater than or less than? It's greater than, so it's or. And so I'm going to put the meat of my absolute value is greater than or equal to the 15, or the meat of my absolute value, and again I have to flip that inequality sign just like I did the last time, is less than or equal to negative 15. And I'm going to solve one side of that at a time. So if I solve on my left, that means I subtract my 3, and I end up with 2x is greater than or equal to 12. Then I would divide both sides by 2, and x is greater than or equal to 6. Now I'm going to treat the other side. And so when I'm solving on this other side, it's going to be the same idea. Subtract my 3 from both sides, and 2x is less than or equal to negative 18. Divide by 2. Divide by 2. X is less than or equal to negative 9. So we started off with the greater, and that means that we're looking for anywhere that's being shaded, any shading point when we go down to our number line. So when I draw my number line, I'm going to go ahead and place my 0 in the center. I'm going to put my negative 9 on the left and my positive 6 on the right. And so if I look at the positive 6, when I shade that, it starts at positive 6 and it says it's greater. So I'm filling it in and I'm shading towards the right. When I do my negative 9, I start at the negative 9 and I shade left. So we have two different spots that's shaded. Because it's or, this is okay. And so my inequalities are going to be negative infinity, comma, I stopped at negative 9, so I'm going to do negative 9, I can actually be there, so it's a square bracket. Unioned with, I started at 6, and I went till positive infinity. So anytime you have an or, there's a possibility to have one of these situations. Example 3. So this one, we now have things on the same side as our absolute value. So our first goal is to get rid of everything on that same side. So minus 8 from both sides. So absolute value of n minus 5 is greater than or equal to negative 18. So let's think about this. Just like with equations, inequalities have special cases too. So when you pull things out of an absolute value, it is always positive or 0. So any number that leaves there is going to be greater than negative 18 because it's going to be greater than or equal to 0. So there is no number that's not going to work for that. Let me show you how you can see it if that doesn't stand out to you. So you can go ahead and work through this problem. n minus 5 is greater than or equal to negative 18. Greater means or. n minus 5 is less than or equal to positive 18. And so I add my 5 to both sides. N is greater than or equal to negative 13. Add 5 to both sides. N is greater than or is less than or equal to 23. So when I come down to my number line, I'm going to go ahead and put my 0 in the center, my positive 23 on this side, and my negative 13 on this side. And I am going to shade in the information. So let's start with the negative 13. It says n is greater than negative 13, greater than or equal to. So it needs to be a closed-in dot, and it's going to go towards the left, or the right, excuse me. Then you're going to do the same thing for the 23. It's again closed-in dot, and I'm going towards the left for less than. With or, which is what we separated it with, that is the anywhere that's shaded. So if I was to sandwich these together, the entire number line would end up being shaded. So when I do that in inequality or in integral notation, that's negative infinity to positive infinity, or all reals. So negative infinity to positive infinity, which is the same thing as all reals. Let's look at our next example. So we need to get the absolute value by itself before we can start doing anything else. So the things that are over here that are do not belong is that negative 8, so we need to add 8 to both sides. And that gives us negative 9 times the absolute value of 4x minus 7 is greater than or equal to positive 25. Now, I'm going to divide both sides by negative 9. When I divide by a negative, that is going to, oops, that wasn't 25, 27. When I divide by a negative, that causes my inequality symbol to switch directions. And that gives me a negative 3 on that side. And now I have the absolute value by itself, and I make the determination. Is this an and or an or? Less than is and. And so I put my meet is less than or equal to negative 3. And 4x minus 7 is greater than or equal to positive 3. Let's talk about this at this step. Anything that comes out of an absolute value is always positive or 0. So is any positive number going to be less than or equal to -3? And the answer is no. And I'm showing you the work below to show you what you'll see if that's the case. And remember, and is the overlap. So when I solve this, I get +7 plus 7. 4x is less than or equal to 4, divided by 4. And x is less than or equal to 1. On the other side, +7. And 4x is greater than or equal to 10. And x is greater than or equal to 10 fourths when I divide both sides by 4, which is the same thing as x is greater than or equal to 5 halves. So these are my two inequalities, and it's an and, so I'm looking for that overlap. So I'm going to do a sketch of a number line up here on the top. So 0 in the center. And then I have 5 halves, that's 2.5. And then I have also 1. So from the 1, I am shading towards a closed dot going towards the left. From the 5.5, I have a closed dot shading towards the right. Do these ever overlap? No. So this is the null set. That's your answer. This is the no solution or null set.